Hello, everyone. This is Nivas Shankar, Principal Product Manager from AWS Lake Formation team. I'm here to talk about an interesting topic, building data mesh architectures on AWS. So there's a lot of interesting topics, technical deep dive around it. So let's just giddy up. So I have an interesting agenda for this session. We'll talk about some of the challenges and the business opportunities that the customers and organizations are seeing with the data, what they are and how they're trying to overcome it. And we'll also see that how those challenges led to an evolution of data mesh type of an idea, which created a paradigm shift around on how to be driven and domain-driven centric organization. And also we look at very closer way around on AWS Analytics Services to build a data mesh kind of a capabilities and what the services are and what are all the capabilities that brings up to the building a data mesh environment. And we'll also have a very closer look to the data mesh principles and some of the design patterns on how some customers are adopting this design for their organization and how does AWS kind of help around in different scenarios and bringing them closer into the data mesh model. We'll also see a brief demo around on this data mesh topic, and then we'll summarize with some of the advantages and pros and cons and what are the key benefits that we have seen the customers operate on this model. Let's just get the brief preface of the problem statements, right? So with the reinvention of the data that is happening all over the board, we have been really clearly seeing that the customers are adopting most informed decisions and domain-driven insights from their data. And by having cloud and other cheap storage and the compute instances at a scale available, they're all setting up for the reinvention of the data very clearly. And this gives them a more opportunity for them to play with the data, bring most of the insights closer to their business outcomes. And that is actually taking them into a journey into a data-driven organization. And what that means is setting the strategy towards how the organization and line of businesses should operate. And they're giving clear evidence that those data-driven insights is making their directionally higher proposition for our organization to grow, and as well as rely on some purely on the entire data for driving their own businesses and their outcomes. So what typically customers have seen in the past work, we'll see a journey of how customers have adopted this, right? So in past, the customers have always brought up different source systems into a relational data warehouse type of an instance where they would do a typical reporting analysis of the data, and then they will support all the businesses for financials, for regulation, for compliance, and for running the operations model and everything. Over the time, we have also seen that the data types have increased and changed a lot, which means any unstructured data like devices data coming up, sensors and machines data sending it up. The data warehouse have become a typical challenges in those times where they really couldn't really able to meet that scale to support those different open formats and still able to drive insights around it. So with that problem statement, they kind of moved towards a data lake kind of a model where a data lake came up with a construct around on supporting all these structured and unstructured data types that comes from a different parts of the source systems and still keeps the open formats. And then that lead to an ability to run something like a machine learning, AI, and BI analytics very closely into those common data lake environment. And that also supported the traditional data warehousing style of reporting as well. So which made them much closer into the data, and then they give them a lot of ability to run more insights and then more closer to look at how their organization worked and functioned accordingly. However, we have also seen that the centralized data lake does not reflect how some of the organization works within that model, right? It is very clear that when you bring data closer into the data lake environment, there is always a difference in the executable goals as well as how business line of business wants to deliver. So they had to really meet all the requirements around business units from a common data lake, which provided this centralized catalog and then able to get extracts to the data sets and run their set of use cases like machine learning, BI, or analytics type of use cases. So what it does is it kind of recreates the issue around on depending on a centralized data lake or a kind of a data warehouse model. And they have to typically rely on IT teams to be able to support and create their own instances of workspace around the data lake environment, and then depend on ITs to be able to provide access to the data sets for their own set of use cases. So that created this pace of innovation much lower in this model. Also, very importantly, when different line of businesses have different goals and they have to rely on a common central data lake kind of an environment, that created much more operational challenges for them to maintain their consistency and compliance and cater to a very simple use cases like can they able to scale at their own level of growth that they are forcing in this organization specific needs. So it really created a low ability for them to deliver from this model. And it works for some organizations, but we have seen that in the enterprise scale, this centralized lake model is still have to be supported in much larger way than what they've envisioned when they moved to the data lake environment. And that created a set of challenges for them to look at how they're consuming the data, right? So in the centralized model or in data warehouse or a lake kind of a setup, the sharing and the searching of the data become much difficult because there were two different types of open formats, and the data is actually in much larger ecosystem where for them to run and use cases around it. It's difficult to meet all the requirements around different business units to keep it consistent with the common security service, common arching infrastructure. And if somebody has to share data from one organization to another organization, they would simply create a policy and then allow access to the data, but they've lost control on what the consumers actually did on top of the data. Very typical problems we have seen in the data sciences, like if they want to easily able to find the data sets that they think they can provide a value out of this data sets, they will have to have a request access, and then the business and have to depend on IT to be able to provide access to them and then share with them in a much larger workflow cycle. So that created a very monolithic type of dependencies with a common IT team, and business was running a very limited way of autonomous into their deriving the business units and everything. So they always needed to create this kind of a model that, hey, can we really work through the concept of supporting producers and consumers type of a data, and can we really create a set of pipelines and data sets that are isolated from teams so they have this independent autonomy to be able to make the decision even with the common service platforms, right? So in that, that's where this type of evolving data architectures we have seen that has been taking over from few years from now. So typically, from a data warehouse kind of worked probably earlier 2015, where all the systems were able to bring into the data warehouse and they were able to run data warehousing type of analysis, business reporting, and business intelligence kind of insights around on the data warehouse type. But as we've seen that the data types and the open formats have increased over the period of time, bringing all the data much closer into the data lake environment actually led to a much more valuable analytics piece of the data, where big data platforms have kind of evolved, where they've kind of gone into the distributed model and also led to the very efficient way of running a machine learning model closer to the large storage based instances and everything. So even with that, as we've seen the problems with the organizations and the policies and the adherence to the data sharings becoming extremely challenged in the model, customers are moving towards a modern data architecture kind of a model these days, where they really wanted to have this closer integration with their data lakes, analytics, and database and machine learning, all governed within the right instances within sharing a data from one to another. And that also led to a multiple patterns where you could see that the data mesh is one of them. And that's where the topic of today's session is going to be really diving into that. What is that data mesh actually does in the modern data architecture space? And that within that modern data architecture space, you'll also see that how scalable data lakes are actually evolving within this model in top of this particular data lake setup, and eventually moving towards a much more governed type of data management, which is brings the unified data access, security, and the permission management. Like how do we do that within the modern data ecosystem? So we'll look at all those things closer from a technical point of view. And as we see that they're going to still evolve. So right now, there is no right answer around on how they want to manage it based on how organizationally they are evolving and changing. So this will definitely bring up those ideas and new concepts like data fabrics, data mesh, and then data managements, metadata open managements across your cross platforms. So there's a lot of interesting ideas are being innovated within the modern data architectures. And now that they've kind of seeing the challenges and now they wanted to really try out these different patterns, we have clearly seen the customer ask for the following areas where we have seen that they've asked for organizational autonomy and self-service. So provide them an ability and infrastructure to able to run and maintain their own data lake, which provides a different set of use cases. And you not have to depend on a common IT team or one team to be able to manage all the other set of capabilities that business wants to run. With the diverse set of personas coming around in the data world, they're also seeing that they need to support different type of personas like analysts, engineers, stewards, auditors, or a data science or a workspace analyst who would come in and able to get some different insights based on their potential and skill. And data privacy and compliance are extremely becoming important these days in the cloud environment and as well as in the modern data to support regulatory needs and then HIPAA compliance to make sure that the data is secure and data has also been adhered to the standards that they are sensitively maintaining and managing their data. That also brings that any collaboration that happens within the data, there is also a clear, secure sharing mechanism, and then all the consumer-based model who are consuming this data are operating in a much more governed and controlled environment. So with this ask, now we will see that how data mesh evolution has happened with all these challenges that has been in the past, and what are the ideas and thought process that the data mesh actually brings up. I want to take a moment to credit Zamak Dehani from ThoughtWorks. She came up with this idea around the data mesh around 2018, 2019, where she really talks about the data mesh as a paradigm shift that how we think about the data platforms, right? The idea of moving away from this monolithic architecture into this distributed domain driven architecture, making a platform self-serve, and then having a kind of a product thinking makes the data much more valuable, which is the part that I really like about this data mesh concept, where you're really enforcing more of a valuable data that you're going to establish in your organizations and create a domain driven decentralized architectures for each line of businesses and data owners to own it. So she does touch upon four key pillars, which we're really truly support of those pillars, and we're going to be aligning with our technologies and architecture patterns around that. Number one is the domain-oriented and the decentralized data ownership and architecture, so which really creates an organizational autonomy within the data lakes that we've kind of seen around, like the data platform. Like, how do we create autonomy for business to operate on their own? And how do we make sure that each data owners are treating their data as a data product, which gives them a true ownership and the true authorization for them to manage their life cycle of the data and maintain the quality and integrity of the data? And how would we provide as a platform team, as an IT, that's operating this organizational autonomy with a seamless self-service infrastructure platform that gives them a most common security layer and infrastructure framework that they can able to operate on? While this distribution happens within decentralized in the product way, how can we still give them a governance, which is through the federated computational governance perspective, to keep the security and compliance in a governed way and able to see that how you can how people can access data from one organization to another organization in a secure way. So I would highly recommend to read this book from Zamak. She wrote a very good, interesting, deep dive concepts around on mesh and the ideas behind some of those principles we touched upon here. There is also Martin Flower article that's been published around this. That's kind of gives you the preview view of data mesh too. So what is data mesh? And from an Amazon point of view, if you want to take those ideas around on the principles that has been touched upon, it is a decentralized, domain-oriented modern data architecture that enables a governed sharing of data products across one or more data lakes. Think of each of the data lakes as their own organization who maintains the data and who manages the data around different purposes. How would we provide them a kind of a governed sharing to different consumers who would want to access those data products across one or more data lakes. And within that context, how would you provide a seamless governance where you're really unifying your policy managements across how the data has been shared, and you're really centralizing your governance and audit around on how the platform and organizations of data mesh has been set up? And what are all the ways that you would really give an authorization to your producers or domain owners to federate their access, and how they are going to govern and manage their access control to their for the consumers? And also creates the capabilities like organizational wide sharing so that the data as such is available for discoverable and also for purposes like running their set of use cases according to the user consumers. So this gives a very broader picture that taking all the organizational autonomy and the self-service and the more of a federated governance, stitching it together, it is actually enables the governed sharing of data products across one or more data lakes. And how would you still support this decentralized and domain-oriented modern data architecture? Why data mesh, right? So if you take this approach and then align it to the model that the data lake or any other data platform worked, some of the things that we have seen the customers work on this AWS platform is just encourages data-driven agility. So they have this various ways to able to improve uh, their innovations and improve their autonomous to able to bring in more valuable insights around on the data. It also supports their own local domain-centric governance. So each of the domain owners are responsible to maintain their own data sets and value. And it also provide those policies around on how they wanted to control and maintain it in a much more unified way. It also created an accountability from one domain to another domain. So each domain owner takes a clear responsibility to maintain the data integrities, making sure this data is valid and being democratized for setting access within their own domain as well as sharing outside of the domain. And it also created this more of a much stronger data as a product or a product thinking, which can exist in multiple systems, and still the domain owners and the product thinkers can able to bring that closer into it. So now we'll go on to some of the AWS Analytics Services, which actually is very easy to understand to build some of these patterns like data mesh and what they are and what are the key capabilities it brings up. We'll look into much closer now. The first thing we talked about is the around on the domain centric decentralizations, right? So if you take a modern data architecture platform within one domain, the closer the data, which actually operates for various purposes, like bringing up the data in a data lake, or having a different type of instances for serving various use cases, like purpose-built databases for running some NoSQL related use case, or bringing a machine learning closer into the data and running an insights. All of this data can able to rely and able to share outside the perimeter and as well as inside the perimeter into the data lake environment. So that brought up a domain centric closer into how each of the organizations can able to scale within this modern data blueprint or a pattern, where each domain can be perceived as a modern data architecture. Scalable data lake platforms can they can able to maintain and manage their data sets, and also can able to understand different use cases within their construct around on keeping different types of data in different instances. Also, the data movement becomes much easier within this model, where each organizations can maintain their data sharing from one instance to another instance, and the governance around on maintaining this modern data architecture become easier, where authorizing and permission controlling around on the data that is in a lake versus in other instances become much closer into their domain centric point of view. It's also very performant and cost effective within this data domain, that how they want to be able to scale and how they're able to bring in more data and more value into their domain, so that more people can able to understand easily within their domain perspective or point of view than looking at the broader sense of data and figuring out how what they are. For building a data lakes, we always recommend Amazon S3, which undoubtedly is the most durable and available and scalable services that we have. It also provides a much more storage options, archival capabilities, and then also the very key capability is to store data types in different standard open formats, where customers can bring in different type of formats according to the choice and keep it in S3 and use that as a mechanism to able to control their object access controls. They will control the security compliance and around different ways to get the data into the S3 services. It's cheap, it's slow, and it's efficient in maintaining the data in Amazon S3 services. Also, from the other services like lake formation, you could easily build, manage, and secure data in your data lake environment. So in order to bring your data into the data lake, you could create an ETL workflow using services like Glue and EMR, which works with the lake formation model to authorize it. And you could catalog your data sets that you have been registering in your data world. And you could really run your transactions and your storage optimizations around your data sets. And that simplifies your data ingestions and into your data management within your data lake onboarding process. Once the data is in the data lake, you can define centrally and manage all your security and governance, which is typically operates at a more of a DB style permission, which means that if you want to grant access to certain accounts, like certain organizations, certain principals, you could do so seamlessly within lake formations as a more of, let's say, select, grant, and describe kind of a permissions on the data catalog that's actually operated on the DS3 location. With the scale option, you could also think of more of aligning your data objects or data tables into an attribute-based access model, where you could define some of classifications within the data sets. And using those classification of tags, then you could provide a fine-grained access permission and a catalog permission to the outside organization or within your organization for principals who wants to able to consume the data. The more interesting feature we have in the lake formation is to share those data sets in a much more governed and secure way, where you could share your data into a cross account. You could share your catalog for discovery purposes for what are the type of data that exist in your organization. And it can also seamlessly helpful for centralizing your audit with the kind of a mindset that who accessed data, what was the data that was brought into this environment, and what are the time that the consumers were accessing your data for their use cases. And AWS also has the most serverless options that you could ever have in the cloud. It brings all the analytical capabilities closer into a managed service and a serverless option, whereas services like Glue and EMR can give you a big data processing as a scale where you want to run a large compute process without managing your infrastructure. You could do so, and if you want to have your data warehousing capabilities, or Amazon Redshift serverless can able to help you with that to really run a data warehousing at scale. All your streaming and analytics like Kinesis and managed service Kafka can able to provide you a streaming based ingestions around on these capabilities. And for visualization and data reporting, or maybe more interactive use cases that you want to run against on the data sets, you could use services like Amazon Athena and then Amazon QuickSight for visualization. For all this data management and security around the data side of it, you could use lake formation as a services to able to manage and maintain in a serverless way. Now that we have seen the ideas of data mesh and the analytic services that is capable of building this data mesh, let's look at into closer view of how this data mesh is actually in action in principle, that we have the four principles we talked about and some of the design patterns that customers are adopting it. Before we go into those patterns, I just want to highlight some of the principles that we have been recommending customers around organizationally, right? So as a data producer or a data owners, allow your producers to create a data products and then make sure that you have a life cycle of those data products shared in a contracted way. So which means that if any of the data sets has to be allowed access for certain consumers or another producers to be able to look at the data, make them as the available data sets for the time that they need, or for the time they will want to use this and create different products on top of that. Also provide an efficient means to safely publish and secure data, so that all the data set that is maintained in the data product world are being secured and being able to publish in the right way. Also, giving the data product owners the ability to create a single model for identity and data classification provides us really good value proposition for data products to maintain their own data sets. and they alone are responsible for maintaining this identity and the classification of the data set that is responsible for that specific domain, and mandate this type of a system for data sharing using a resource share. So as an organizational or units or from a data owners or domain centric standpoint, what is the resource that has been shared and what is the life cycle that associated with that resource share, to be able to understand and able to secure that. Set this as an organizational goals on adoption and create an inspection mechanism that how this really works when you're really setting up this data mesh environment, how the resources are happening and how the cross platforms are integrating with one instance to another instance, and use that as a mechanism to publicize your success around sharing those data into the different teams, and create an entitlement policies. That means create a type of a life cycle of a permission management to say to what type of permission that this particular organization or across platform or across accounts would need access to your data sets, and what are all the ways that you would want to share the data sets from one team to another team. And I think you also seen those four principles. So let's just look at closer to those four principles and see how AWS is solving this problem in the AWS ecosystem. The principle number one is a decentralized ownerships, right? So we have really clearly seen that this leads to a persona called data owners around maintaining the domain centric ownership. So they are responsible and accountable for their data products that are to be reliable and available and accurate for all of their organizational reporting, and as well as all of the product that needs to be consumed by other organizations. Also, it also clearly creates an ability for them to classify and also make sure that the quality of the data is correct. So they are responsible for this domain ownership within their organizations. Think of that as more of an organization specific point of view, where one data owners can own a line of business or probably a multiple line of business, and they also have a different type of accounts to be able to maintain and manage the data sets according to their need. Which means if somebody wants to run an operational data around on the data to curate the data sets for operational use of the business, they could have their own segment of the accounts to be able to manage that. And they could also run more analytics and machine learnings and create a source type of a system, which is more in a raw format within their own account. So that keeps their organizational point of view closer into their data owners personas. And some of the things that they could do once they have the data ownership is to register and catalog data sets. They could protect and secure organizational data, that how they want it to be allowed to be consumed or to be shared. And they are responsible for managing the data quality around on what are the type of quality rules that they want to run and apply on top of this data products, and definitely maintain this ease of use of atomic integrity, so that they know exactly if this data set has to be shared to a different organization, what is this data set can be valuable for other organizations. So they maintain this ease of use, and making sure that it is accessible. It really relies on this ownership of the data owners. They're also responsible for accountability for data exchanges, which means that how the data has to be shared and complied with other restrictions. They kind of set these rules and they kind of verify this fit for purposes within their data sharing purposes. That brings up the concept of bounded context, right? Where if a certain LOB is asked to rely on another line of business's data for them to run and curate the data sets, how would all of this cohesively work within that bounded context, so that data products can able to take a certain relevant data sets out of their line of businesses and able to own it for their set of specific business purposes. So this creates this entity of domain ownership, like how they wanted to maintain the integrity of each domains as a bounded context, and able to manage and go deeper into those data sets that they are responsible to able to find and highlight insights on. And similarly, as a data as a product, this is a combination of two roles where we have seen a data steward and engineers work closely. So they make this domain-driven design techniques to be able to formulate and establish a bounded context for data products. So once the data is in their environment, what are all the ways they could really bring data into a much cleaner shape as a more of a product thinking, so that they could apply all the data registration, all the data to detect and classifications around the data to make it really consumable data product across their organizations. So their data engineers are sometimes responsible for ingesting data into their respective S3 buckets, and they would want to operate and operationalize a set of pipelines they own and operate. And then data stewards can able to delegate, or producers can able to delegate engineers who are responsible for a full life cycle of the data. So in order to run their ETL processes, or in order to run some of the archivals, and then making sure your life cycle of the data is relevant to their organizational goals, they may maintain and manage that. They also kind of catalog all the data sets, so it makes it easy for discoverable and accessible by different consumers, knowing what the data sets are, what the data products are, and what are all the set of catalog that comes along with it. Uh, Producers also, as the stewards, also control their access through a federated governance, so which means in order for them to maintain and manage their own respective data sets, they could do so within this data product world, so that they alone are responsible for maintaining and managing the data sets. Coming to a self-service platform, some of the visions that we see from an AWS point of view here is to provide an ecosystem of data infrastructure with all the protocols that the data consumers wants to consume the data for their different type of use cases. Let's say if they want to run an interactive analytics or machine learning or data warehousing or visualization capabilities, how would you provide them a seamless automated provisioning infrastructure so that they could able to quickly able to get to the data that they are really entitled to, and able to run all their use cases around this data. So for an example, if a data scientist comes in and able to request access, then how would we provide an access request to the data consumers so that the permissions granted are at that defined fine-grained level, either redacting the data for their own use case of running a model, or running a fine-grained permissions at a certain segment of data that's sitting in an organization for them to consume it. So all this data access can be validated and audited in the federated data governance perspective, so that any data access that is granted or query that has been made against from the consumers all the way into the data lake can be audited and then can be inferred from the governance standpoint. So with that, we'll also look at how the federated governance model would work within this construct, right? So this is the really a key importance there. The model, we really think that it's going to work around on the decentralization and domain specific access is through this decision making model that is led by the product owners, so that there is no still that central team or a single team who is dependent on maintaining this governance, but how would you provide a governance where each owners are maintaining and managing it. So in that model, let's just look at few scenarios here. Like let's say if a data domain owner brings in the data sets, they manage the data products, which is product A in this case. And similarly, if a domain owner B brings in their own data sets and they manage their own data products B, which is only accessible and controlled by their access provisioning that they maintain and manage it. Similarly, n number of producers and n number of domain owners can bring it into the data sets into this common data catalog or the federated governance account. And by the help of data stewards who are really responsible for maintaining the governance cycle around the data and providing the security that is needed for the organization across consumers, they could use help with the data engineers to set up this attribute-based access control around on the data sets and enable access auditing, like how those data sets are registered and being consumed, and create an entitlement processes where a domain owners can able to use those entitlements to able to share to the consumers. So let's say if a data science comes in and then request access to the data product, say, how would this particular operation should work on it? It's like the domain owners would come in as their permission. They want to authorize against a data product A to the data scientist. And they could also use the same mechanisms to share to the different consumers within the same model too. So that creates another aspects around on auditing all of your data products, registrations, and sharing of data all in from a PCI and SOX compliance perspective. So if auditors wants to understand how the data management platform is maintained and how the data sharing happens from domains all the way into the consumers, then they could able to really get into this federated governance and able to get insights around those centralized audit perspective. So this really provides us common security features at the core to govern a data mesh environment, where a common identity providers are really classified at the producers level, consumers level, and then you'll able to maintain an audit simply by providing a decision base to identify what is the type of calls that have been made to the data sets from different consumers. Since the data products are being exposed as more of a metadata type search, you will see that how this federated metadata search is also helpful for organization to able to go to one place to discover these catalogs. Again, when it comes to the access, the domain owners are responsible for granting access and so on. And they could also define their entitlements and permissions model within the fine-grained access control tool. And that creates a central place, as I said, talked about on centralizing all your audit processes and compliance in one place, so you know exactly how the data is maintained, registered, being consumed and shared from one organization, domain owners to another organization. So with that, we'll look at some of the patterns that our customers are really adhering to. The number one is the central organization. So let's just take a scenario where a customer is running as a one central organization, which combines of combination of products, combination of consumers, all operating within a single account, and how they wanted to be able to address the data and how they want to be consume it. Let's look at this closely. If you take one organizational unit, let's probably break it down into two simple components. One is a products, another one is a consumer. From a product standpoint, a domain owners would take the data that has been ingested from their source system into the data environment. And they would first step is to register the data locations and then populate the metadata prescriptive to the data products that they think is valuable for their organizations, which means they could update the database, table, columns, attributes, and tags around those data set that's coming in from their source systems. Using those data catalogs, they could still run their own set of transformation and enrichment and curation, which constantly updates those metadata information in our services called lake formation. So which keeps it consistent with the product evolving schema or the product evolving changes that the domains foresees in their lifecycle management. And when those data has to be shared to the consumers, the data product or the domain owners can simply able to just share those resource back into the consumer personas or the principals, and those consumers would able to understand what the catalog that has been shared according to their access that has been granted, and they could create somebody like permissions around on this catalog for their set of services like Athena and Spectrum to able to run on top of this catalog. So which gives them a very clear path around on separating your data products and as well as consumers, where your data and your data catalog lives in the product domain centric world, and the consumers would come in and just come in as a self-service platform to be able to get the access they need for it. And seamlessly in controlling this access pattern, you're controlling through a federated governance, like how the access and the entitlements are shared from one account to another account. And similarly, from different design patterns, let's look at how each federated business wants to operate within central organization. The classic example would be is business would want to maintain their own data sets and the consumers would want to be able to run their own insights. But centrally, you wanted to be able to govern how the data sets are shared and how the organizations are really trusting on the data that they're being shared on what purposes and what entitlements. Like the similar model, if one of the organization brings or ingests the data into their data lake environment or their domain organization, the first step is to register the data sets in the central federated governance account, which means they would want to populate all the metadata of their data products they registered, and they would share those same metadata back into the organization for their own curation, transformation, and enrichment, and all the domain centric operational activity that they wanted to make. Domain owners or the data producers and stewards are still responsible to maintain and manage this data sets around on the data domain organization. So which keeps it closer that all the changes around on the data product world are constantly reflected in the metadata world in the central organization, and they will regularly get each domain owners from all the other perspectives so that it's intact, and then the population of the metadata is also consistent with how producers are envisioning it. When those data sets has to be shared back to the producers, then the producer owner who delegates either a steward or engineers to grant permission, they make them responsible to share those entitled data sets back to the consumer organization. And like the same model, the consumers would able to get those catalog back into the consumer organizational catalog, and they would create a resource link on top of that and grant permissions to their own consumer personas to further delegate the permission model for them to consume services like Athena and Spectrum to able to run a query data sets against those catalogs. So which makes it much centric to the consumers, how they wanted to delegate permissions, enforce fine grained permissions, and then enrich their data sets based on use case. And domain owners still keep that data onto their domain and still keep curating and then maintaining and managing their life cycles. But from the common governance standpoint, your federated governance kind of gives that control towards how the data sets are being coming up and how the data sets are shared and how it is being consumed by the consumer world, all in one common federated way. Using the same model, you could bring in more consumers who would want to run a different use case. And you could also bring in more data domain organizations who would want to come in and follow the same processes. So that way you register your data sets, you go through a common protocol with the central fair governance account, and you make sure that your data catalogs and all the other data sets are shared securely within the organization. Let's look at some of the third design patterns, which is the how do we support a federated business and a decentralized organization? They're entirely different. They maintain and manage their own catalogs, and how would we want to support that? So this is one set of organizations where if you take the previous model and align into this one, like each organization maintains their own products and consumers. So all the definitions of the domain ownership, data attributes are given specific to their domain ownership level of policies and permission management. And similarly, you also have an organization too who would want to do the same thing according to their own choice. So they bring their own data sets, catalog, and they decide to share within their own consumers, like how they wanted to consume data within organizations. So bringing all this thing closer together, if you want to really create a discoverable catalog against two different business organizations, you can create something like a central organization catalog where you bring those catalog back into the central organization. So that will keep a common organizational wide specific data registry. And you'll also know what are all the type of data that's coming from different organizations that is kind of lived and managed from each organization. And then from a data to detect and classification perspective, you know how those data are classified from what perspective into the business domain and the producer standpoint. If some of the organization decides to share their data sets to a different organizations or different consumers, they could continue to operate in a much more decentralized way. So they need not have to depend upon any of their processes. Their organization catalog can still able to request access to a different organizational data sets, and those organizational personas are responsible to share back to their different organization consumers. So that way, each business can able to operate on their own decentralized way, and then you would know what type of access are being granted and being shared from purely from a ownership standpoint within the organizational domain owners. And from strictly from a data discoverable purposes, keeping your consistent data catalog refreshed in an organizational wide search, and that's where we are seeing that the central catalog would able to maintain and kind of abstract this organizational wide data assets in one common place.
We have seen the overview of data mesh and what our AWS Analytics Services are available to build. Let's look at the demo part of how to build a data mesh, and then I'll walk you through the brief demo of how the different combinations of scenarios like producers, governance, and consumers come and play when it comes to registering a data and sharing a data and a permissions model around it. So in this scenario, we'll just consider three products where a product owner owns the data in their own account, and then three consumers who would want to consume different combination of data from different product domain owners, and how those are all seamlessly enabled through an unified permission model and then data sharing aspects from the federated governance standpoint. I think the utility consists of very simple 5 steps, like a data mesh owner grants a producer access to come into the environment, sets it up the environment so they could register the locations, make them as an administrator for managing the data sets. And then the producers or the domain owners creates a data catalog from the data objects within the data buckets. And then how producers can still own and manage their own data sets for kind of publishing their data for consumers, and how would producers would approve access for consumers to get access to the data set the consumer need. And then we'll also see how consumers would query the data in their own console like Athena and can able to query data on it. So with that, let me take you into the screen. So I have a bunch of accounts, which is the central governance account, which will have all the data catalog, and then a few producers and a few consumers account. Let's just go into one of the producers two account and then see how the data is set up and the locations and registrations are all happening. So we have created a bucket called data mesh producers two, and then I have a simple sample data called taxi data. And you would see that the permissions that I have on this data buckets are pretty simply to let the central governance account lake formations to control the bucket list and get the delete, get objects, and put objects kind of a permissions. With 047 is one of the central governance account which will have complete control to it. So which means you don't need to work on any additional permissions on bucket policies to open up for any roles to be able to manage this data set. So now that the objects are in there, let's just go back to the lake formation. You will see that there is no table that exists around this particular objects. Let's just go and populate the data. So I'm just using a simple scenarios called crawlers to be able to run and able to populate the data tables around this object. So this would what this crawler does is it goes and infers the S3 location and then able to use the lake formation permissions to able to create data tables and then populate all the schemas around the data object that comes through it. Now we see that the new tables got added. Let's just go and verify in the lake formation console. Right, you'll see that a new data called taxi data got populated under the data product 2 database, and they own the complete ownership of this data set. So which means that all the schema populations and everything are intact for producers to own in their own accounts, and they control all the data sets and schema evolution and all the other changes necessarily. So when this producer decides to go grant access to different consumers, let's see how the central governance account forms. So in the central governance account, you will see that a similar way of onboarding data from a producer standpoint. All other producers from 1 and 3 and other n number of combinations of producers would onboard the same type of data. And you would see that all the data sets are populated from different producers' locations. And when you really federate it into respective accounts, which is, let's say, if I log in as the producers towards who's responsible for their own data sets to manage and administer permissions, I would only see the data sets that I am authored to control and manage, which is producers toward 2. You'd see that the tables got populated as part of the previous producers running the catalog, and the same changes is reflected into the central catalog. So this kind of idea keeps it consistent that however the producers manages and maintains their data set, the central governance would automatically know from a metadata standpoint that the things have changed, and these are all the ways they would capture all the catalog consistently. Now let's see that how you wanted to share those data sets back into the consumers, and then we'll see one scenario. So in this case, if I were to grant permission to a external account called, let's say, consumer 2, which is 9647 account, I would just simply add the external account, and I would just say, give this particular product 2 database, taxi data, give them a select and describe permission. And then if you want the other accounts to be able to also be grant permissions to further delegate to the permissions, you could do so. So you could just select the grantable permissions for just at that level of permission that you grant. And once you grant it, it probably lets the other external account know that they can control this particular data sets at the selected permissions level. Since now the data is shared, let's just go back into the consumers and see how this is all coming up. I've used a different console just to show the difference. So if I were to log in as the lake formation here, since the data sets are shared from my producers back into the consumer account, I would see this particular data sets is already enabled. And then from this table, I would see that the new data set that's shared from the 047 accounts are shared to my account. And all I have to do was to simply create a resource link out of this table. So this is one scenario of how I created a resource link pointed to the main share so that you could play around in a consumer world that I have seen this resource share coming up from the central account. And just to keep it simple, I also created a resource link pointing to the resource to call that this is another resource link table pointed to this particular shared data. And I would grant the permissions to a consumer analyst or any of the other analyst who wants to see fine-grained permissions around it. Once I've granted it, I would probably go back to services like Athena, and then I would see a table around taxi data. And from there, I could preview a table without copying any data into my consumer account, just simply lake formation, providing a permission model from a centralized governance to the consumer account, and then consumers to be able to read access to the data sets, which is originally in the producer account that you just saw that I ran a crawler and then enabled the schema and all. And then the consumers were able to read the catalog within this consumer account. So this is a scenarios where you could probably understand this in single organizations where an one-to-one mapping can happen. Directly, your producers can share it to the consumers as well, or through a cross-account scenarios where you share it to the centralized governance account, and from there you could share it. So that kind of brings up a model that how the data sharing becomes easy and a decentralized architecture of data remains in their own account.
All right. Now that you have seen a demo, let's look at the summary of what you've learned in this last 1 hour session, and then we'll just wrap it up with the data mesh ideas and what AWS is doing around the space for the future. Some of the advantages of having a data mesh model here is to acknowledge and further build the ownership of a data. So you're clearly seeing that how the data ownership relies on the data domain owners and how those data are operated that made sense for them. So to really give them a way for them to innovate on their behalf. It also removes any dependencies on a central team. So you don't have to have teams to depend on it. So the producers can entirely manage the data sets. They can facilitate sharing and they can really understand what the data sets means for different consumers. As you've seen, it's mostly technology agnostic, so you don't have to really rely on any of the services or technologies to be able to do this sharing registration concept. It also scales with the time and team, so you don't have to probably concerned about how much of data scale that would come in as the lake formation or catalog, and to be able to share it. All are probably met with the scale aspects. It can also provide a strong security, governance, and protection. As you've seen that all the data objects which are in the data lake products are controlled and managed by the data lake formation service. And from the cost standpoint, you'll see that most of this automation requires engineering. So all the behind the scenes of enabling this environment requires some of the utilities and the environment build aspects. It is also more complex for analysts than using one warehouse. So they want to understand where the data discoverable is, so they could go and request access and bring all the collection of data. I think that's somewhere the complex relies on what type of data that you want to expose it. The required skills are more aligned to the domain owners, where they would all be responsible for how to make the data available, how to manage the data lifecycle of managing the data, rather depending on the IT teams. Keeping this in the mind, some of the customers who are really kind of gained by this data mesh that we have seen constantly within our AWS service adoption is it enables organization to be autonomous. They really increase the pace of innovations on how their model works and how their autonomous perspective around on maintaining and managing data is really works at a scale. And this modern data architecture kind of really fits perfectly, providing a common tech stack to simplify a data mesh. So you don't have to rely upon different technologies and choices to be able to build different set of capabilities. And from a lake formation standpoint, it really simplifies your building a data product, which is mostly your catalog, security, access, and sharing of data sets. And when it comes to the native integrations, all the services like EMR, Redshift Spectrum, Glue, and Lake Formation, they all kind of cohesively work with the Lake Formation model so that you can able to share the data sets and also being able to manage your permissions around your Lake Formation service. We're also working with our third-party solutions who would want to enable these services for their own set of self-service analytics and ML using lake formation services. So that works in a broader ecosystem within third parties to be able to integrate into this model. With that, we have really seen a brief overview and a demo of a data mesh environment. I really hope that everyone enjoyed this session and kind of understood what the model that AWS can provide and support. Again, my name is Nivas. Feel free to reach out for any questions, and then we are happy to help. Thank you.